There is a spider on the ceiling. You saw it 3 minutes ago, and you have not stopped thinking about it since. You know rationally that it is approximately the size of a small grape, that it is not moving, that it is almost certainly one of the several hundred spider species that shares your home and has been sharing it since before you moved in without either of you realizing or consenting to this arrangement. You know rationally that the probability of this specific spider doing anything to you is somewhere in the range of essentially 0. You are still watching it. Not in the focused analytical way that you watch things you are curious about. In the specific, automatic, peripheral attention-consuming way that your visual system watches things it has classified as potential threats. Part of your brain is tracking its position even when you look away. If it moves, and you can sense at the edge of your awareness that it has not moved, your full attention will snap back to it within milliseconds. This is arachnophobia in its mild, extremely common. Most people have some version of this form. Not the clinical, life-disrupting, cannot enter a room if there might be a spider version that approximately 5% of the population experiences. Just the specific, universal, remarkably consistent human tendency to find spiders unsettling in a way that seems disproportionate to the actual threat they represent. And here is what makes this interesting. You did not learn this. You did not have a traumatic spider experience as a child that created this response. You were not taught that spiders were scary. This response was installed in you at a level that is deeper than learning, older than experience, and far more ancient than any cultural context that shaped your personal history with spiders. This response was installed in you by ancient humans, by the specific survival challenges of the ancient world, by a selection pressure that operated across tens of thousands of generations and produced a human nervous system that is, in a very specific and very functional way, pre-configured to pay attention to spiders. Let's start with what arachnophobia actually is at the neurological level, because it is not what most people think it is. Most people think of phobias as learned fears, responses that were acquired through specific negative experiences, and that persist because they were not unlearned. This model is correct for some phobias, but is demonstrably insufficient for spider fear. The evidence that spider fear is not primarily learned is strong and comes from multiple independent directions. First, the epidemiology. Arachnophobia and subclinical spider fear are among the most common animal-related fears in human populations worldwide, appearing at significant frequencies across cultures with radically different spider fauna and radically different relationships with spiders in their cultural frameworks. Some cultures have traditions of spider consumption, spider worship, and spider keeping that are directly opposed to the fearful relationship that other cultures have with spiders. Yet the prevalence of spider fear remains elevated across all of these cultural contexts compared to the prevalence of fear of non-threatening animals. Second, the developmental evidence. Infants show enhanced visual attention to spiders and snakes at ages before any conditioning experience could plausibly have occurred. Studies with 6-month-olds who have essentially no independent experience of spiders show that spider and snake images produce elevated pupil dilation responses compared to images of flowers and fish. Pupil dilation is a marker of sympathetic nervous system activation, the physiological correlate of the stress response. Before infants can walk, before they can have had any direct experience with spiders, their nervous systems are already treating spider images as threat-relevant stimuli. Third, the conditioning asymmetry. When researchers attempt to create conditioned fear responses to different stimuli in laboratory settings, pairing images with mild electric shock, they find that fear conditioned to spiders and snakes is acquired faster, reaches higher intensity, and is dramatically more resistant to extinction than fear conditioned to images of flowers, mushrooms, or modern threat objects like guns. The brain is not treating all stimuli as equally valid fear conditioning targets. It is specifically prepared, specifically primed, to associate spider-like stimuli with danger. This prepared learning, the concept proposed by researcher Martin Seligman to describe the specific ease with which certain associations are formed and the difficulty with which they are extinguished, is the fingerprint of evolutionary preparation. The human brain treats spider stimuli as a special category because it was built to treat spider stimuli as a special category. Let's talk about why. What was it about spiders in the ancient world that justified this level of neural preparation? The straightforward answer is venom. Venomous spiders have been a consistent presence in human environments across the full span of our evolutionary history. In Africa, where Homo sapiens evolved and where our hominin ancestors spent the majority of their evolutionary history, venomous spider species are abundant, widely distributed, and responsible for genuine mortality in unprotected populations without access to anti-venom treatment. The black widow spider and its relatives, the Latrodectus genus, are distributed across every inhabited continent except Antarctica, and have been present in African environments throughout the evolutionary history of the human lineage. Black widow venom contains alpha-latrotoxin, a neurotoxin that produces a syndrome called latrodectism. Severe muscle pain and spasm, sweating, nausea, and in some cases cardiovascular complications that without treatment was a significant mortality risk in ancient populations, particularly for children, the elderly, and individuals who received large doses relative to body weight. The Sydney funnel web spider, arguably the most medically significant spider species in terms of recorded human mortality, is geographically limited to Australia, but funnel web spiders as a family are distributed across multiple continents, and their combination of aggressive defensive behavior and genuinely dangerous neurotoxic venom made them a real threat in the environments where ancient humans encountered them. The brown recluse and its relatives, the Loxosceles genus, are distributed across North and South America and parts of Africa and Europe, and their venom produces necrotic tissue destruction that, without medical treatment, could result in severe and potentially life-threatening wound infections in the ancient context. A necrotic spider bite that destroyed significant tissue in the leg of an ancient person who needed to walk for their survival was not a trivial medical event. The point is not that all spiders are dangerous. Most spiders are harmless to humans, and many are actively beneficial as pest control agents. The point is that in the environments where ancient human evolution occurred, the category of spider included a non-trivial proportion of genuinely dangerous species, and the identification of which specific spiders were dangerous required a level of taxonomic discrimination that was not always practical in the time frame available for real-world encounter assessment. Let's talk about the specific cognitive challenge that venomous spiders posed to ancient humans, because this is where the evolutionary logic of prepared spider fear becomes most compelling. The problem with venomous spiders as a threat category is that they are extremely difficult to distinguish from non-venomous spiders through the rapid visual assessment that is all that is available in a real-time encounter. Unlike large predators, which are large, obviously dangerous, and easily identifiable at distance, venomous spiders are small, fast-moving, visually variable, and often encountered at very close range before detection. The time between detection and potential contact is very short. In a threat category where rapid identification is difficult, where the cost of a false negative, treating a dangerous spider as safe, is significant, envenomation, potential death, and where the cost of a false positive, treating a safe spider as dangerous, is low. Mild avoidance behavior, brief elevated heart rate. The evolutionarily optimal strategy is a general prepared alertness to all spider-like stimuli rather than a discriminating response that requires time to assess individual threat level. This is the specific logic of what is called an error management bias in evolutionary psychology. The idea that when the costs of different types of errors are asymmetric, evolution produces biases toward the less costly error type. Missing a venomous spider and getting bitten is significantly more costly than falsely alarming to a harmless spider, and wasting a few seconds of vigilance. The optimal error management strategy is therefore to produce an alarm response to all spider-like stimuli and sort out which are actually dangerous after the initial avoidance response has provided some safety margin. Ancient humans whose nervous systems produced this general spider alarm, who paid enhanced attention to all spider stimuli, moved away from all spider stimuli reflexively, and conducted their more careful discrimination from a position of increased safety distance, survived and reproduced at higher rates than ancient humans whose spider response was calibrated to require prior discrimination. Over generations, the general spider alarm response was selected into the human neural architecture as a prepared response that does not require individual learning to be present. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Let's talk about the specific visual features of spiders that trigger this prepared response, because the trigger is not spider as a conceptual category. It is specific, low-level visual features that spider bodies share. Research on what visual elements trigger spider fear responses, using artificially constructed stimuli to test which specific features produce enhanced visual attention and stress responses, has identified a consistent set of trigger features. Multiple legs, legs that are thin and angular relative to the body, radially symmetric arrangement of appendages, and the specific movement quality of spider locomotion, the rapid, unpredictable, multi-directional movement that spiders produce when disturbed. These features are consistently more aversive than the overall shape of the spider body, suggesting that the threat detection system is operating on feature analysis rather than whole object recognition. The brain is not recognizing this is a spider, and then generating fear. It is detecting specific visual features, thin angular legs, radial symmetry, unpredictable rapid movement, and generating the prepared alarm response that these features trigger, which then produces the conscious experience of fear that the person attributes to the spider. This feature-based triggering explains several interesting aspects of spider fear. It explains why spider toys and spider images can trigger fear responses even when the person knows they are not real spiders. The threat detection system operates on features, not on semantic knowledge of what the object is. It explains why people whose arachnophobia has been partly treated through cognitive behavioral therapy often report that the fear response returns immediately if the spider moves unexpectedly. Movement is one of the primary trigger features, and unexpected movement reactivates the threat detection system, even after voluntary approach has been achieved. It also explains the specific horror that comes from the feeling of a spider on the skin when you cannot see it. One of the most consistently reported peak arachnophobia experiences. The detection of movement-consistent tactile sensation in the absence of visual confirmation of what is producing it triggers the prepared spider alarm in its most urgent form because the feature detection system is receiving one of its trigger signals without the visual information that would allow discrimination. Let's talk about the ancient human experience of living with spider fear as a functional biological system rather than a disordering anxiety. Because the ancient context was very different from the modern one, and the fear served very different purposes. In the ancient world, the prepared spider alarm was not an inconvenient quirk of a nervous system that had not yet been updated for a low spider risk modern environment. It was a functional component of the general environmental threat monitoring system that ancient humans relied on continuously for survival. Ancient humans sleeping on the ground, on grass bedding, in shelters with organic walls and floors, in the specific close proximity to the soil surface that ancient sleeping arrangements involved, were sleeping in environments with substantially higher spider density than any modern bedroom. The specific microhabitat of ancient sleeping spaces, warm, sheltered, with organic material providing structural complexity, that spiders use for habitat was, from a spider's perspective, excellent habitat. Ancient humans were sharing their sleeping spaces with spiders routinely and unavoidably. In this context, the specific heightened alertness to spider presence in the sleeping environment was not a phobia. It was a functional monitoring behavior. The ancient person who noticed a spider in their sleeping area before settling down, who checked the area around their sleeping surface as part of a normal pre-sleep environmental scan, who responded to the tactile sensation of something moving on their skin at night with immediate attention, that person was executing a functional safety check that reduced their exposure to genuine envenomation risk. The ancient woman who shook out her hide sleeping cover before lying down on it was not engaging in irrational behavior. She was managing the specific spider in sleeping area risk with the practical behavioral response that the risk warranted. The behavior would look indistinguishable from a modern person's OCD-adjacent checking behavior around bedding, but the motivation and the functional outcome were completely different. Let's talk about something that is underappreciated in discussions of spider fear: the social transmission dimension, and what it tells us about the relationship between ancient human biology and ancient culture. Social transmission of fear, the acquisition of fear responses through observation of other individuals' fear reactions rather than through direct conditioning experience, is dramatically more effective for spider and snake stimuli than for other stimuli in both humans and other primates. Studies in which participants observe another person showing a fear response to specific stimuli have found that fear is acquired rapidly to spiders and snakes through this observational channel and is extremely resistant to extinction. This means that in ancient communities, spider fear was not only transmitted through direct envenomation experiences, or through the individual neural preparation discussed above. It was transmitted through the social observation of fear responses in community members, through explicit cultural warning about specific spider types, through the stories that ancient communities told about dangerous animals in their environments, and through the specific parental behavior of attending to and reacting to spider encounters in ways that children observed. This social transmission layer served a specific function. It allowed the specific local knowledge of which spider species were genuinely dangerous in a specific territory to be incorporated into the general prepared spider alarm. A community in which the specific spider species most dangerous in that territory were explicitly identified and specifically feared, and in which that specific fear was transmitted to children through social observation and explicit warning, had better calibrated spider risk management than a community relying only on the general prepared alarm. The general neural preparation provides the baseline: attend to all spiders, maintain vigilance. The cultural transmission layer provides the calibration. These specific spiders in this specific territory are the ones most worth serious concern. Together, the biological preparation and the cultural specificity produced an ancient spider risk management system that was functionally effective across the diverse geographic and ecological contexts that ancient human populations inhabited. Let's talk about the modern mismatch, because understanding why spider fear persists at its current levels in modern populations who face essentially no genuine spider-related mortality, risk requires understanding the specific dynamics of evolutionary lag. The human nervous system that is producing the prepared spider alarm response in you when you watch the spider on the ceiling was built for an ancient environment. The neural architecture takes tens of thousands of generations to change substantially. The transition from ancient subsistence life to modern urban existence has happened in a geological instant, a few thousand years at most, covering perhaps a few hundred generations. Natural selection operates on survival and reproductive consequences, and in modern populations, mild to moderate spider fear has essentially no reproductive consequence in either direction. It neither kills you nor reliably saves you. Without selection, pressure in either direction, the prepared spider alarm remains in its ancient form, calibrated to the ancient environment, producing responses appropriate to a world where sleeping on the ground in spider-rich environments and encountering genuinely venomous species in daily life were routine realities. In the modern environment, where venomous spiders are rarely encountered and sleeping on the ground is not standard, this ancient calibration produces responses that exceed what the modern threat level would require. This is evolutionary mismatch, a biological system performing exactly the function it was built to perform, in an environment where that function is less relevant than it was when the system was built. The spider on the ceiling is not producing false fear. It is producing correctly calibrated ancient fear in a modern context where the ancient calibration is partially obsolete. Here is the thing about spider fear that I find genuinely interesting in the ancient context, and that most discussions of arachnophobia completely miss. The ancient humans who had this fear were not paralyzed by it. They were not dysfunctional because of it. They lived full, active, competent lives in environments with genuine spider threats, managed those threats with a combination of biological vigilance and cultural knowledge, and in most cases experienced spider fear not as a disorder, but as a functioning component of the environmental monitoring system that kept them safe. The clinical arachnophobia that we recognize today, the fear that genuinely impairs function, that prevents people from entering specific environments, that produces panic responses disproportionate to any realistic threat, is partly an artifact of the modern environment in which the ancient fear system operates without the specific context that gave it its functional shape. In the ancient world, the fear was present, but the environment provided continuous reality calibration. Sometimes the spider was dangerous. Sometimes it was not. And the behavioral outcome of spider vigilance was a genuine reduction in envenomation risk rather than a misfiring alarm in a threat-free environment. The spider on your ceiling is the ancient world's most common threat category, running in your ancient nervous system, in a modern bedroom. The fear you are feeling is real. Its origins are ancient and functional. And somewhere in the neural circuitry that is tracking that spider's position even as you try to think about something else, the ancient human who survived because they paid attention to spiders is still paying attention. The spider still has not moved, by the way. You noticed that I mentioned that, didn't you?